People are like atoms, and when we go to the most fundamental level of physics, when we look at quantum mechanics, what we end up finding through a bunch of linear algebra is that if we tried to describe the character or predict what an individual would do, what a single particle like an atom would do, it is extraordinarily difficult, and we cannot tell you with any certainty what this will do. If we know something's position, we won't necessarily know its momentum. And so you get a lot of uncertainty principles that arise as a result of this uh, uncertainty. And so the way I look at it is think about a sociologist looking at a group of people. As a whole, we can say that, the market will respond to this particular change, such as a rise in gas prices will cause the market to, in general, drive less because it costs more to travel. Um, you can say the same things about groups of molecules or atoms. You know that if you have a ball that has, a significant number of atoms in it and it's traveling at this velocity, then we can say with certainty that it will hit the target within 10 seconds. Now, when you begin to look at individuals like people, like how do you know how one particular hedge fund manager will respond to bad news? You can have a little bit of confidence that they're probably not going to like it or they will like the news, but you can't say definitively that this will happen. And so, at that level, that's something that's really helped me in my studies and how I've approached my quantum mechanics class to just think about people and atoms. We can, draw up tons of equations and try to model the probability distributions of how someone will react or respond to an event. But again, at the end of the day, what we find when we look at the most granular, finite, fundamental level is that we cannot say with certainty how a lot of things will respond. And the next part here is that when we begin to get into chemistry and statistical mechanics, where we begin to look at more and more atoms, more and more people, and how these atoms come together and how they aggregate into molecules, that is where I see a lot of characteristics of like families or people in groups. So like if I'm with my mom or my brother or my dad, how does our group as a family change? So like how does two atoms of oxygen coming together to form O2, now they take on a different characteristic than a single atom of O2. And what we see again, drawing the analogy to people and atoms, is that we take on different characteristics depending on the different people around us. It's very intuitive to me that people who are around different friends will behave differently. You're a different person to your parents than you are to your friends, than you are to your priest, than you are to your whatever your boss. And so there's a lot of parallels here between people and atoms that I keep finding as I think more and more about this. In addition, when we look at chemistry again and we talk about things like pH or temperature or pressure or volume, these are basically conditions of our environment that we live in. And it's very directly relatable to people. It's like, how will you react if it's really hot or really cold? Obviously, you're not going to like it if it's too hot or too cold. If you're under a lot of pressure, you're going to be stressed out. It's very similar to at a high level looking at the analogy of if I have a nucleophile, an electrophile, and do I want to know if an SN1 or an SN2 reaction will happen, or an E1 or an E2 reaction will happen in organic chemistry based on what the conditions are in my solution, I can try to favor things by creating conditions in an environment to make something like that happen. Thinking about it like a sociologist will look at it, or maybe a government policymaker, like how do you incentivize the market to react a certain way? You put in price floors or price ceilings, or you try to subsidize things, and that's basically humans intervening to try to force something to happen that wouldn't necessarily happen naturally. And so that is again a really good analogy to what a chemist or a chemical engineer would be doing at a large scale, in which we are trying to make a reaction happen. We are trying to produce an enormous amount of some product that is very difficult to make otherwise because it is thermodynamically unstable. And when we talk about thermodynamics and thermodynamic stability, I again like thinking about family dynamics. You know, you have some families where the mom and the dad really don't get along and they're just fighting and bickering all the time, and the kids are just awful. And you know, it's very similar with molecules. Like you have some really unstable molecules like carbanions. Carbon doesn't like having more electrons because it's not that electronegative, and you know, you just have all these dynamics that will take on these characters. Like nitrogen really doesn't like losing electrons in some situations, and so um, you know, when you look at a molecule like oxygen, like O2, the thing that has basically fueled cellular respiration and life and where we are today, what we see is that this oxygen has taken on a very different character as a whole than, you know, an individual atom would. So it's like when I look at people rioting on the news and you see people, you know, lighting cars on fire and protest, it's basically the same to me when you see a molecule so unstable, when you see a group of people that is so unstable. It is very similar, and to me, it's a very beautiful thing to think about. It is probably a little bit weird to think about things this way, but I think a good way for me to wrap up is that when we think about um, the way that you know, good memory techniques, you'll hear time and again in English classes is something called personification. And so personification is assigning characteristics of people to inanimate things. And so when you look at really good mathematicians or really good scientists, they're able to personify things that people usually don't really see as people. And so, you know, if you can begin to look at the world like people, if you can begin to look at an atom or a molecule or a group of molecules like people or groups of people or a society, I think it really helps kind of throw and incorporate a lot more of your intuition into how you look at science and you think about life. And you know, I just wanted to give this perspective and hope that you know, some people can take some things away from it. And you know, at the end of the day, the irony in my analogy is it isn't necessarily an analogy because it is the truth, because atoms are people and people are atoms. So I think that's a pretty nice note to end on, and I hope you guys like this video, and thank you for watching.